Hi everyone, so this video is going to be my informational video on how to perform basic functions in Pymol. What I'm going to do is I'm going to follow along with the Introduction to Pymol instructions that is due for the fun, short little Pymol quiz I've created of you all investigating the different levels of structure of the scorpion venom protein called, it's called butane toxin. I always want to call it butatoxin, but that's not right. It's butane toxin. Okay, so I guess the one big thing to say about Pymol, so something you might need to purchase for this course is a 3-button mouse. Any 3-button mouse will could do. I have just a Bluetooth one. These should only cost about $10. You could order one on Amazon and it'll get here in a few days, or you should be able to pick one up at Walmart, maybe even Kroger here in Georgetown. But so the 3-button mouse it will make your life easier. Can you do Pymol without a 3-button mouse? Yes, you can use your finger pad on your laptop, but big disclaimer here is that you're on your own because it's so frustrating. I find it so frustrating to work with the 1 or 2-button mouse that I will offer almost no help to you because you've chosen that path. So finding a 3-button mouse, you can purchase one. Again, they shouldn't cost more than around $10. Or I've also seen some students grab one in the computer lab and bring it up for class, but then also make sure you return it back to the computer lab. Again, we're going to be using Pymol a lot throughout the semester, so it might just be worth your time to purchase it. Or if you know somebody in your dorm or in your Greek life house that has a Bluetooth mouse that you could borrow on and off throughout the semester, I'd see about doing that. Okay, so let's go ahead and get started. So you all should have downloaded Pymol, the educational edition. And let me share my screen here. Okay, and so then this is what you would see. Sometimes, so in the Mac, it's all together usually, and sometimes if you have like a Windows or just an Android something, I don't know, a non-Mac, you might see a couple different, like this top piece might separate. You might have it in 2 different chunks, 2 different blocks. So it's not all one block, but I don't know, in the Mac, it's all just one block. So a couple things that I would always suggest you do first is at the very top, you know, there's where file would be. Here are the options. You've got file, edit, build, movie, display, settings, scene, mouse, wizard, and help. Movie's pretty fun. Last semester I did have students generate movies in Pymol showing off their protein structures. But anyways, you should click on each one of those and look at what all the options are. So file is your typical stuff. You can open a file, you can save an image, you can save the movie. You could also save your session. Saving session is big, very important, something we'll talk about a little later. But so those are like the 3 things I would imagine you would look at in the file. Edit, I don't really mess with. Build is more, build and movie kind of go together more. So build's like you can have a structure and it can rock a little bit or it can rotate and flip. So that's like adding a build to your movie. Display you will mess with. So display is where you can change your background color from black to white or colorless. And it also has what's called color space. And color space is it changes kind of the brightness of some of the colors. So usually the typical default, the cyan color is just like really, you know, neon blue. But if you change the color space to, I believe it's called CMYK, it says CMYK for publications, that neon cyan is muted a little more and it just looks more appealing to the eye. So usually I have students change the color space so it's not always so like screaming neon colors. Some of the other things that you might use under display is the sequence mode. This is where you can change how the sequence and the primary sequence or just the amino acids are displayed from 1 letter code to 3-letter code, or you could see the chains. So like, for example, hemoglobin is made up of 4 different polypeptides. It's an alpha, beta. And so you could see they'll label those 4 chains A, B, C, and D. So that's also what you can see under display. Settings is where you can mess around with like the transparency of things. That's pretty the only thing I think you really use in settings. Sometimes if you're looking, you can edit a lot. You can change a lot of little details like font sizes and font style. And that would be in the settings, edit all. Lots of options that you can tailor in Pymol. Scene, I don't really use. Mouse, this is where if you are choosing not to use a 3-button mouse, where you can come and click on that you're going to use a 2-button mouse or you're going to use a 1-button mouse. Again, I highly suggest just take a mouse from the computer lab. Don't be that person that's trying to figure it out on a 2-button or a 1-button. It's so frustrating. Wizard is where you'll be able to go to take measurements of things or show the distance between 2 atoms in the 3-dimensional space of this program. And then help is where you can type in your help questions. There's a huge Pymol wiki that'll walk you through how to do everything on Pymol, and you can go to help and then Pymol community wiki. That will take you right there. Okay, so that's like all the things at the top. All right, so then I just want you to kind of look at the Pymol. It's got kind of 3 areas. You've got this upper area right here. You've got a command line right at the bottom of this upper area. You've got what's showing right now is this big picture that said like EduPymol. I just clicked on it, went away. So here's the black screen is where I'm going to see my proteins come in. And then this area on the right over here, this has these bars, and we can add multiple proteins onto this program, and each protein will become its own individual bar. Okay. And they'll always be the all at top, which would edit all of the proteins that you might have imported into this session of Pymol. Okay. Just so that you can see at the bottom where it's written in this like really old computer looking font. This is the mouse mode. So see, I'm in 3-button viewing mode. And so these buttons tell me the left click, middle click, and right click is the L, M, and the R, and the wheel, if you have a wheel that rolls. And if you like left click and hold down shift, that means plus box. And you can mess around and see what all these different things do. Really the best thing to do in Pymol is just get a protein in this display box and just start clicking on things and messing things around. The biggest downfall maybe is that Pymol does not have an undo button. It's okay. You're not sometimes, I mean, I would say you're not going to break the program. In the worst case scenario, close the whole thing down, you reopen it up, and you bring back your protein that you're working with and start over, right? But so there's not an undo, but really what you have to think of when you work in Pymol is you're going to show things and you're going to hide things. So like, let's say you accidentally showed something you didn't want to. Instead of an undo button, you just hide it. Okay, so that's how the undo works in Pymol. So it's a lot of showing and hiding. Okay, in fact, if we look at this all bar, there's these letters A, S, H, L, and C. A stands for action. These are some actions you can do. You can zoom, you can center it, you can origin brings it back to the original kind of like file upload of what the protein is. Preset shows you some different ways, some different presets of how to display your protein. I usually go preset pretty, and we'll do that when we upload our file. So yeah, you can see again, just come through and read what all these different actions you can do are. Show is where you can show things. So you can show things as lines, sticks, ribbons, or cartoons. And you could show things as spheres, as dots. You can show the surface. And then probably really big is I'm really big into only showing the side chain. I don't want to see the backbone, amide bonds and stuff. It just makes it so messy. So when we can show, we can just click on side chains and you can show the side chains as either lines, sticks, or spheres. Okay. Hide is pretty much everything in show except for it's the undo version, right? And they're like, oh, I didn't want to show that. I just go hide that, and then whatever it is you clicked on. L stands for label. You can label a residue. You can label all the residues. You can label select residues. You can label atoms, all kinds of things. And then C for color is the different colors that you can get. So I would say most of the time I like to just color by element. And as per convention, nitrogen's always a blue, like a true blue. So don't ever try to color your carbon backbones true blue, because that's nitrogen. Okay. Oxygen is red, like cherry red. Don't ever make your carbon's backbone turn like red, because that's supposed to be for oxygen. Sulfur is orange. Hydrogens are white, but usually in X-ray crystallography, X-ray crystallography has a limit where you can't see the hydrogens. If you solve your structure using NMR, you can see the hydrogen. So it's okay if you made your carbons white, because most people are going to don't really look for those hydrogens anyways. I mean, we kind of go hydrogen blind a little bit when we're looking at these structures here. Okay. And notice that the C is the color carbon, right? And there really isn't like a true blue or a cherry red. Maybe in some of these further sets you might find it, but you know, they really hold off on trying to mess up that convention. So nitrogens are always blue, oxygens are always red, sulfurs are always orange, and the hydrogens are going to be white. If you want to make like a black carbon, how you would do that is under this color, you would come down to gray, and then you can make something white, or you can make it black by clicking on black. And one thing you would need to do though is that down here, if you're just in these solid colors and it's not the color by element, it's going to make every single atom that color. It's going to make oxygen that color, nitrogen that color, hydrogen that color, carbons that color. So you can pick the color you want your carbons to be from those these color options down here, but then what you have to do is you click on whatever color you want. Like I want it to be black, so I'd go to grays and then I'd hit black. But then back at color, you go to by element, and the very first option, you don't see a carbon, and that's the one you would click. So the one where you don't see a carbon, it's just going to fill in whatever color you selected from down below to be the color of carbon. So that would be how you do that. So let's go ahead though and I kind of walk through the first couple parts of the assignment, which is just like look around and see what all these different things are. Okay, so let's go ahead and fetch our structure. So we're gonna again look at the Brazilian scorpion toxin, this butane toxin, and it's a small protein. So what we can do is we have a command line. We go to the command line up here, or honestly also at the bottom of the display, there's a second command line at the very bottom. So you look for Pymol with a greater than sign. Remember I said I'm bad at greater than less than. That's the greater than sign, because the less than sign makes an L. Still always takes a minute for me to remember. Okay, so we're going to type in our first command. We don't really work too much with commands, which is good. We are more over clicking on those buttons that are like action, show, hide, and color. So, but our command to grab these coordinates, so it gives us the three-dimensional coordinates of all the atoms in this protein, is fetch followed by the 4 alphanumerical identification code. So for the scorpion one, it's 1C55. So fetch 1C55, and then I hit enter, and there it is. So it has fetched the coordinates for that protein. Okay. If you have your mouse, you can hold down the left click button, and you can kind of see how you can turn this thing all different ways. If you hold down the right button, you can zoom in and out, right? So these are all of our amino acids that are making up our protein. Now this is really hard to look at because it's showing us just where every single atom is. This is where, see over here, on my bars, I have the all bar that was there before, but now I have the one labeled 1C55. That's my protein bar. So I'm going to go to A for action, preset, and then pretty. And what it does is it turns it into the secondary structure. So it shows off the secondary structure in cartoon for me. Normally, it honestly usually shows it color-coded from blue to red, blue being the N terminus, red being the C terminus, because the blue terminus starts with a nitrogen and nitrogens are blue, and the red being the C terminus because it ends in the carboxylic acid and the oxygens are red. But yeah, so, okay, well, mine was white. It was probably because I was messing around with the color box before. Okay, but so right off the bat, you can tell that this protein has one alpha helix and one little anti-parallel beta sheet. So that again is describing the secondary structure. And again, you can kind of turn it, twist it, move it, rock it, all kinds of things. All right, so that brought the, made it easy. I think it just made it visually easy for us to look at. Let's just show you. So if we go to show, let's show the lines. So lines is what we saw originally. So lines are going to be really thin, atoms. Essentially every atom is a very thin line. If we go, let's color it by element, just because I don't have that option on here. I'm just going to pick this green. Color by element, green. Ooh, I just have an issue with color coding. Yellow? Huh. Green. Well, that's weird. I've never had that issue before. I probably would just stop the program, close it, and reopen it. But that should have turned it green. Okay. Let's just do that anyways. I'm gonna close it, I'm gonna open it, I'm gonna do it again. So I close the program, now I'm gonna reopen the program. I'm gonna share my screen. I mean, I don't think an undo button would have gotten me out of that issue. All right, here we are back at the blank thing. I click on this, go in my command line, and I fetch 1C55, enter. Ah, there it is. So that's what it should look like there. Okay, we fixed the problem. All right, so see, it brings it up as lines, but remember, we can go to action, preset, pretty, and now it's colored blue N terminus to red C terminus. Nice. Okay, that looks good. Let's just go ahead and color by element. I'll color everything like that green though. So carbon will be green, nitrogens are blue, oxygens are red. I cannot emphasize that enough. Those colors, can't pick those ones because they're taken. All right, so then we can show the lines. So that is on top of the cartoon. That's showing all of the atoms coming off of the backbone here. So actually, it even includes the backbone atoms, but I see right off the bat, right over here on the left, there's a tryptophan. I see one. What's this? Right here on the right, there's a lysine because there's a lot of carbons and it ends in a nitrogen. So that's a lysine. What do we have down here at the very bottom of this alpha helix? I see an arginine because I see a lot of green carbons and then 3 nitrogens with a carbon in the center. That's that guanidinium moiety. So there's an arginine. Oh, look, here is a tyrosine right here, right above it, because it's got the ring, but the alcohol with the oxygen that's red, right? So you can start to identify amino acids right off the bat. That's lines. I think lines are ugly, so we're going to hide the lines. Let's show the sticks. So sticks are going to be a little bigger, okay? And again, like I said, let's hide these hydrogens. So hydrogens muck everything up. They just add like way too many elements. So if you want to hide something, right, go to H for hide. So we click on H for hide and we go down and we find hydrogens. I want to just hide all of them. All right, hydrogens are gone. So now I'm just looking at the structure this way without the hydrogen. So things look a lot cleaner. Okay, so usually if you're going to show off the side chains of certain amino acids that are important, I want you to do it in sticks, not lines. All right, but let's get rid of sticks. So we're going to hide the sticks. And then, so the next one is ribbon. So you can show the ribbon and it's going to be over that cartoon. So ribbon's just essentially the cartoon mode, but it's very thin. Watch, I'll hide the cartoon. So there's the ribbon, but it just shows you the single backbone, like where it goes. You can kind of see this alpha helix here. You see this, these 2 lines. I don't know if you would know that that's a beta sheet or not. I couldn't tell you. So that's where cartoon is really helpful. So let's hide the ribbon and let's show the cartoon. So cartoon's really helpful because it shows us immediately, gives us that secondary structure information off the bat. So here's our alpha helix. It's corkscrew. It looks beautiful. This is a beta sheet because I've got 2 of the arrows, which are going to be the sheets, and they're pointed opposite of one another. So they're going in opposite directions, which is anti-parallel beta sheet. So you got an anti-parallel beta sheet and alpha helix. All right, I feel like we're getting comfortable here, right? So let's move on to one of the questions here. So we made it pretty. Oh, I said in my intro, I said color by element cyan. Okay. Well, I picked green, but you can pick cyan. So color by element cyan. Ooh, let me show you that the color display change. So this is like that really bright cyan that's just like, oh, a little neon-y. So if you go to display and you go color space, you click on the CMYK and see how it just takes that like cyan and mutes it to this really nice, cool blue. So, and again, this is more for publications because when you're reading a journal, I swear the publishers don't want those neon colors screaming at the readers, right? They want these nice muted tones. Okay. We could also change the background space to white because if you were to print out some of these images, black is going to suck all that ink. So to change the background, again, you would go to display, background, and just click on white. All right, so see, we got our beautiful structure coming along. Okay, let's show how you show the primary sequence. So the primary sequence or the primary structure, remember, is just the sequence of amino acids. So there's two ways to do it. If you go to display, you can go display or you can hit sequence on. Okay, that's one option. The other option is down here at the far right bottom corner of the Pymol, there's this letter S. And that letter S stands for sequence. So you could click on that and it'll bring up the sequence here. Okay. When I just clicked on that and dragged it across, I was selecting and highlighting all of these different amino acids, which is what all these pink dots are. So anytime you see these pink squares with a little white center, that's just a selected residue. Okay, so I selected the whole thing. See, I can kind of get rid of some of those if I wanted to, and it took away those selections. Another interesting thing is if you wanted to maybe just like color only the alpha helix. So I kind of like move this around. Maybe I click at the top of the alpha helix and up here in my sequence, it highlighted that the top of this alpha helix is this letter A. And if I come kind of move this around and click on the bottom, it says the bottom of that helix is this letter S. So maybe I want to change the color of only the helix. So I have now at least defined the upper and lower residue codes, and everything in between is what I want. So I could come and kind of, highlight in my sequence up here these, and then I could in these bars on the right, it goes all 1C55 and then CELI, which stands for select. So that's only the selection I've chosen. So I can color just that selection a different color. So maybe we want the alpha helix to be pink, right? Maybe we want our beta sheets a different color. So I can click here and here. So just kind of top and bottom and fill in the gaps here and here and fill in the gaps. And then I would go under the selection bar because I only want to mess with what I've selected. I would color by element. Maybe we want green there. All right. So, I mean, this is just, I just immediately highlighted the different secondary structure in different colors, right? Like this is super fun and super cool. Let's say you select some things and you were like, oh crap, I didn't want that one selected. What you can do, there's a couple options. You could try to find up in your sequence, you can just start clicking on things and figure out what one did you not want accidentally selected. Or the other thing you can do is kind of start over. So to unselect everything, just click in the white space, click away from the protein one time and it'll, just erase it. So you can move this around and kind of start again. So maybe, you just want the upper and lower limits there. Okay. Last thing, let's just show you how to use that. So that was the sequence. I say, oh yeah, so we're going to show the side chain. So let's show all of the side chains here. That is one of the last things on the walkthrough instructions. So under the bar that says 1C55, I want to show just the side chains, all right, as sticks. All right, so that what it does is it's not adding the backbone atoms, so it's leaving the cartoon shaped backbone, and then it's just putting the side chains out of that cartoon. Okay, again, since this was structure so small, it was solved using NMR spectroscopy, and it has these hydrogens on it. I don't want to see these hydrogens. There's just too much junk, too much garb. Plus I got this white background and the hydrogens are white. So how do we hide the hydrogens? You go to under the 1C55, or it could be under all because you just want to hide all of the hydrogens. So either one, but hide, and then hydrogens, all of them. Ta-da! I can zoom, I can move it around. And again, you should practice making sure you are recognizing some of these amino acids, because we will be using, like I said, Pymol extensively. So like right off the bat, here's an arginine, there's that guanidinium, here's a tryptophan, backbone. What do we have here? A little methyl group with an alcohol at the end, that's serine. And you can check yourself by clicking on it and then coming up in the sequence and seeing what the letter is. Okay. Phenylalanine right there, big time, just a big ring. Like I said, tyrosine right there, letter Y. Here's again another arginine. Oh, there's that lysine. So here's lysine. Because remember, it's lots of carbons with a nitrogen at the end. And remember, sulfurs are yellow. Maybe I said orange in the beginning. I meant yellow. So sulfurs are yellow. And so here, for example, there's one cysteine and there's a second cysteine, but notice that they are covalently linked together. So that is a modification to those cysteine side chains to make a cysteine bond, or another word for cysteine bond is a disulfide bridge. Okay, so I've got one of those. Oh, I got more than one. I got a couple, but that's part of the quiz. So I'll let you determine how many total disulfide bonds you have here. All right, so really the intent of the quiz is just to kind of get you playing around with Pymol and then uploading some images. So let's say this was one of the images that I'm asking you to upload. So I would try to center it, make it look great. Here's an example of something that looks terrible, is if you do something like this and take a big picture of all that, because whatever's in this whole display box is what the image is going to save. I can't see anything, right? So zoom in, get it nice and oriented and how you want it. Oh, how do you move traverse, right? So when I was all zoomed out, this was like up here. How am I moving, just picking that structure up and moving it? That's the middle mouse button. Okay, so if you click on the middle mouse button and hold it and move your mouse, you're just traversing your structure. Okay, so I can zoom in right with the right button and I'm like, oh, I need to move that down. So I traverse it. Now I zoom out a little bit. Maybe I rotate it, right? You want to try to fill up this space, or also maybe show off whatever it is that I'm asking you in the image to show me. So like if the question wanted to see about just the beta sheets and it asked for an image, I would probably want to get those as centered and easy to see as possible, right? If it was asking for me to show me the beta sheets, don't show me this side of the protein. This is the alpha helix side. I mean, it seems commonsensical, but come on. All right, but usually you just want to kind of get it squared up in this box. And then when you're ready, you can go to File, Save, Image As, and I just have the option to save it as a PNG. So just click on that and then it's going to bring up a box and you can designate a place on your computer to save it and then just upload it into the quiz. I think there's maybe 4 or 5 upload images I want to see. This also brings me to a really good point where once you get an image that you like, and this might be for if you're working on a bigger project and you want feedback from me on a picture or an image that you've created, you want to save the session. Okay, so right now, if I hit File, Save Session As, just so I can name it and everything, it's going to bring up the box and I can save it as, maybe 1C55 secondary structure. I'm just going to save it as 1C55 secondary. And save. Now, what happens is either maybe your computer might crash, right? Well, let me just back up. We did a lot of work to get to this point of this image that I liked, that I think is good. And so we don't want to have to open up a Pymol and start over from scratch again. So that's what saving the session is going to do. It saves all this work. And once you like close this program, you can reopen your session and it brings you right to this point exactly. All these color schemes, this layout, this orientation that you, whatever you save the session as. So like if you were working on a project and you wanted some feedback from me, like, is this a good picture or whatever? I can get pretty particular with, ooh, if you just rotated it just a little more, get rid of this white space over here, just traverse it just a little bit, that would be better, higher quality publication picture. So if you had saved your session of the image you're asking for feedback from, then all you have to do is reopen that up and then do the little tiny tweaks that I mentioned. If you didn't save the session, then you're going to have to start from scratch. And that is a daunting task. I learned that the hard way when I was making images for a publication that I didn't save the session. And then my boss said pretty much exactly what I would tell you. Can you just rotate it like 4 more degrees to the left? Can you just change the color of this from that to this? And man, it's all, I had to recreate from scratch those images. And that was just when I learned, oh, save session would have saved me hours of time. Okay. All right, so that's the importance of the save session. I hope this Pymol instructional video helps you and kind of inspires you and gets you excited to start investigating at the microscopic level, right, at the atomic level almost, what these different structures are and the amino acids that they're made of.